7.6 video notes, guys. We're looking at percent error. So let's do some keywords, vocabulary of absolute error. So an absolute error measures the difference between the approximate, which will be shown with the letter A, which is the estimated value, and the exact true value, which can be shown with the letter E. Okay? It can be solved by finding the absolute value of the difference, which is subtraction, between the approximate value A and the exact value E. So this can be showed with the absolute value of A minus E. Okay, now I want you to brainstorm some different words that could represent an approximate or an exact. Now I'm going to give you what I want you to write. All right, so these are the words I want you to put in for approximate and exact, those keywords that identify what's if it's either approximate value or exact value. Now, number one, we need to use the formula, the absolute value of A minus E, to find the absolute error. I'm going to call it AE, absolute error, to find those in these two problems. So, absolute value, absolute error equals the approximate value minus the estimated value, or minus the exact value. So we need 150 milliliters in this problem, but we measure 147. So the approximate value is 147 minus what we needed, which is the exact amount, which is 150. Subtract those, and you get the absolute value of -3, which we know absolute value is always positive. So this turns into 3. And we want to make sure we keep our units. So this is 3 milliliters. So our absolute error in this science experiment is 3 milliliters. All right, number two, I want you to solve for AE. So find my absolute error in number 2, and then check with me when you're done. All right, number 2, so 56 was the approximate value of, or what they measured, the student measured it to be, but the actual mass was 53 grams. So they're a little bit off from the true measurement. So the absolute value error ends up being 3, so it ends up being 3 grams, which is the absolute error. All right, now our percent error definition. So percent error compares the absolute error to the exact value. So an example of when you might have percent error is a student measuring the mass of an object in science class. So anytime you've measured something or you've done an experiment in science class and you have had a measurement, there's a percent error involved. Okay, so here's our formula. It can be solved using the percent error equation, in which the values are plugged into the formula below. So here on the right side is the proportion. On the left side is the equation. Okay, so I want to rewrite this one, okay, because we like to have the percent over 100 on the right side. So we're going to write this proportion as the absolute value of approximate, or actually, yeah, let's write approximate. If you want to shorten it as just A, that's fine. Minus exact divided by the exact equals percent over 100. This is going to be your friend here. This is the proportion that most of you are going to want to use. Now you could use the one on the bottom. Okay, that one is going to be useful for kids that will remember from how it was taught last year. And then this is the equation. Okay, so it's percent error as a decimal equals the AE over exact. I'm not going to use this equation very much. We're going to use the proportion. Okay, so number 3. During a school assembly, Mrs. Quinn takes an attendance and counts 356 students. In actuality, there were 376 students. So we need to find the absolute error first. So go ahead and pause the video. Find my absolute error, which is absolute value of A minus E. You should have gotten an absolute value of -20 as your AE, and that turns into 20. So 20 students is my absolute error. Now we need to use our proportion to find our percent error. So our percent error, we'll do this one together, equals the absolute error divided by exact, and that's equal to percent over 100. We're going to use this proportion to solve. So our percent error ends up being, so 20 over exact. Exact is 376. equals percent over 100. Cross multiply and divide, and you get your percent error to be 5.3% when you round to the nearest tenth. All right, flipping over the back page, I want you to read number 4, look at the table, and then we're going to start looking at letter A. All right, so in this competition, they want the car to travel 10 meters, okay, but their cars didn't travel that far, so we need to find the absolute error for each car. Okay, so for Emily, your AE is going to be the absolute value of the the expected amount is 10 meters. So 10 is going to be my exact. Our approximate here is what each car traveled, which is 9.2 for Emily, minus 10. You get 0.8 would be the absolute value. So 0.8 for Emily. Jerome is 10.6 minus 10, which is 0.6. Go ahead and do Maricela. Maricela ends up being 0.2. Check my work. If you have a question, let me know. Now, we need to find the percent error for each of these, Emily, Jerome, and Maricela. I'm going to do Emily with you, and then you guys do Jerome and Maricela. For Emily, percent error equals your AE value, which was 0.8, divided by your exact value, which is 10, or the expected amount, equals percent over 100. So go ahead and find that. When you cross multiply and divide, you get 8% for Emily. All right, I'm going to pause the video. You do Jerome and Maricela. All right, so 6% for Jerome, 2% for Maricela. If you didn't know how to do that, let me know and I'll help you. Now let's talk about what these percent errors represent. So the larger percent error you are is the further you were away from what was expected. So these cars should have been able to travel 10. So the further you were away, the larger your percent error was. So what does it mean if you have a smaller percent error? So Marcella, for example, she only was 2% away, right? So what does that mean? Well, it means a smaller percent error indicates that the car was built closer to the needed specifications. So whatever Marcella did when she built her car, she did a great job so that car could travel as close to 10 as possible. Okay, that needed specifications. Okay, so let's answer D. Read each letter of D, and then we're going to talk about it. Jerome has the smallest percent error, true or false? Jerome had the medium one, so that's false. Emily's race car was the most accurate. Well, that's false. We know that Marcella was the closest, had the smallest percent error. So Marcella actually was the most accurate. Emily and Marcella had a negative percent error because their cars traveled less than the desired distance. Well, no, because Emily and Marcella had a negative percent error. They didn't have a negative percent error. They had a positive percent error. So that's false. All right, last question. Read number 5 and be ready to talk about it with me. All right, so we have an actual amount of gumballs of 408. We had a lowest guess and a highest guess from students. We need to find the absolute error and the percent error. Go ahead and find the absolute error for the lowest guess and the absolute error for the highest guess. Look at my work. You got an absolute error of 26 for the lowest guess and an absolute error of 48 for the highest guess. So we're going to put that in our box here. All right, now use that information to find the percent error for each guess. All right, check my work. I did your AE value, which we already found in the tables, divided by exact, and then equals percent over 100, cross multiply and divide. And you get 6.4% for the lowest guess and 11.8% for the highest guess. Think about who was closest. Yeah, it was the lowest guess person. They were only 6.4% off compared to the highest guess, which was 11.8% off from the actual amount of gumballs. All right, guys, go do the you must do, and then ace that mastery check. Good job completing 7.6 video notes.